hopefully that works now.
Yeah.
Yeah, there is a way to get access to the coding agents, which doesn't involve paying OpenAI or Anthropic. I would totally understand if you don't wish to do that. However, it is an order of magnitude more complicated. And I will sort of give you the hints for how to do this, and your mileage may vary, I'm afraid. So we'll get to that in a second.
Yeah.
I would say we just start with a completely empty terminal if you've got that. So I'll say it a couple of times, I guess. The purpose is the idea I have in mind is I go from like nothing to basically writing a paper according to the workflow that I have established. So I assume that you know nothing to begin with. Some of you know stuff, right? And some of you will be like, oh, this is boring. But hopefully they'll come.
Spending money useful and so on, so now we will be
Thank you. So I'm very happy to be here. I've given a version of this workshop type thing in many places. And in my experience, it depends on the audience very much. That's why I haven't prepared no slides. My idea is I will start by showing you how to get a coding agent installed on your system. If you already know what to do, then you know what to do. If you don't, then you can just watch me do it. And then we'll go from coding agent to how the basic way to use a coding agent, then the workflow tips that I know are very helpful. And then already, I hope within 10 to 20 minutes, we'll have a coding agent. So as everyone enters the room, so there's this talk or workshop or seminar or whatever, I'm going to use a lot of terminology. And terminology that comes from the software engineering industry. And the reason this terminology is important is because the people who created these models are software engineers. And for them, this terminology is natural terminology. So there's this terminological barrier to using coding agents for anything other than software engineering. And there's two ways to go. One is you just deny it and say, I refuse to use this terminology. Or the other is you just say, okay, I accept, I'm going to need to learn some terminology. And as a consequence, there's a bit of a learning curve. I'm not a software engineer. I've learned these words from listening to software engineers. And these words are very helpful words. So I'll say them often. If there is any word you don't understand and you have a laptop or a phone, then immediately go to your favorite LLM and ask, what is that terminology? This is the first way to bootstrap your capability is to just get in the habit of using the LLM to explain the terminology to you. So if I say PRD or TDD or some weird acronym you've never heard of, and I forget to define it, just immediately just be asking or Googling or Gemini or whatever this terminology, because that is a blocker. Terminology is always a barrier to entry to any field, but it is helpful. Occasionally, I might write some of the terminology on the board as it happens. Okay, the first thing is I'll talk about so-called frontier labs. Frontier labs are just the companies that are making the big models. So there's 3 of them that are really, well, now there's 5. So it's OpenAI is the original of ChatGPT, Anthropic is for Claude. We have Google with Gemini. We now have, again, XAI with Grok. Grok has now turned out to be a much more powerful model. There was a recent drop. And Meta or Facebook creating New Spark, which is also an incredibly new model. These are the American frontier labs. There are, as I said, my stated goal for this seminar is to show you how to get a coding agent running on your computer. You don't have to do it, but I think it's worth experimenting with. But you got to know the risks, and the risks, I think I should say right up. If you install a coding agent on your computer and you allow it to have permissions to do anything on your computer, in principle, it could delete everything on your computer. In principle, okay. I'm not going to pretend that it's otherwise. So if you're really concerned about the safety of your device, of the info on your device, maybe get a cheap laptop to experiment on to begin with. That is, you can use sandboxing and so on, but I think that's a lot of extra effort to go to, and they're not even safe anyway. The best agents can get out of sandboxes and do damage to your computer anyway. So be aware that in principle, a coding agent could delete your entire hard drive. Absolutely. That's yep.
But also, I mean, if you install like some virtual machine on your laptop and then you run the agent on the virtual machine, still you can.
In principle, I can't guarantee you that that's safe.
Okay.
Because the frontier models know how to hack out of virtual machines. Yep.
Wasn't there this famous case? I think it was fatal, right?
Yeah.
Which broke out of the sandbox at some point during testing. So
yes. They can do it, and they do it to be helpful. You know, if you say, "I want you to get this done," and they're like, "Well, in the sandbox, I can't do this, so I better get out of the sandbox to help the user." And then, you know, it's like this is the chain of logic which can lead to catastrophe, right?
Well, but if that's the case, then you should really be only using this at like an internet cafe, on your home network, because
it might hack it. Yeah, and so this is where I was talking a lot about trust. Now, I myself have this laptop. I don't mind if everything gets deleted on the laptop. I think that that's about the right level of trust for these things. These models aren't, malicious agents. They're not malicious. They're trying to be helpful, but things can happen. Accidents happen. It's up to you to establish your level of risk appetite. And you can start the coding agents with permissions. You can start the coding agents with permissions on, and I'll do that, and you'll see what happens, and you'll quickly see why I did what I did yesterday. We'll talk a bit more about that, I'm sure. So what is a coding agent? I told you yesterday, it's just a while loop. As part of your training, you should write your own coding agent. This is like the first exercise you should do. And I'm going to show you three that I think are good in many ways. So Claude Code is the one I tend to recommend the use of. Right now, I would say if you can have a Unix-like environment on your computer, that will make your life very much easier. So if you're running Windows, install Windows subsystem for Linux. Does anyone here run Windows? I'm seeing a lot of ThinkPads here. Okay, then your life becomes instantly easier if you install WSL or Windows subsystem for Linux. That's already a virtual machine. And if you run your whole, it's like a mini Linux inside your Windows. And you can run everything in Windows subsystem for Linux, and then you've already got kind of one layer of protection. If you don't let it touch the hard drive, then it's pretty safe. That's I very much recommend either having an Apple device where you've got a Unix-like operating system, or you run Linux on your laptop. That makes your life so much easier. So assuming you've got to the point where you've got Linux or Mac or WSL running, you go to one of these web pages and you simply copy this install line. And the next thing you should be able to do is invoke a terminal. So I hope most of you know what that means. And if you don't know, then it's time to go and Google that. A terminal is the kind of the bare access to the file system that it provides you with a host of commands, and you can navigate around the file system and you can execute commands. It's like how computers used to be, right? So you can look at folders. You can make folders, so we'll make one now. And then I will go into the folder, change directory into the folder, and then I can list the folder entries. I can look for hidden files. So if you've seen this kind of thing, or you've done this once or twice in your life before, then hopefully you're kind of familiar with the terminal. And that's probably all the familiarity you need. You don't really need much more than what I just showed. So once you've done that, you've created some folder on your computer, you want to install Claude Code, for example. And this is the moment where you have to pay your money, right? To use Claude Code, you will have to get a subscription. To use Codex, you'll have to pay money. You'll have to get a subscription. Codex is from OpenAI. That's the ChatGPT one. Try in your IDE. Where's the terminal installation? Codex installation terminal. These companies are all trying to sell you. CLI, of course. These companies are all trying to tell you to use their big apps.
There's also a button in Close Codex up there.
There it is. Thank you. There again is one of these commands. Curl is a command that just executes a web fetch. So it's like it goes and does the thing on the web that Chrome or Safari would do. Yep. Yeah, it's a huge benefit. You have complete control and you can see everything. These apps add layers of obstruction and obfuscation between you and the model and show you less information. They give you more power and they cost more tokens. So what we want is, we want to do this from the ground up. I want you to be able to access that LLM function directly, right? Nothing in between, as close to the model as possible. Encoding and working in the terminal with these coding agents allows you to do that. And I claim it's not much extra work. These fancy apps that they're just now creating are an experiment. Nobody really knows if they're the right way of working with these models. So I warn you away from the fancy apps, actually, because they just released. Some of them were released last week. And they are very much in experimental status. And I think you'll learn less with them. It's a classic example of where something is making your life easier means you'll learn less. This way, it hurts a bit at the beginning, but then you'll just at least understand everything. So you find these curl scripts, and then you want to install Codex, for example, and then you type that in the command line. And I'm not going to do that because I've got Codex installed, but it'll install the coding agent, and then the next thing you'll be able to do is invoke the coding agent, which we'll do in one moment. I want to show you one other route. So this is if you pay money here to Anthropic, to OpenAI, but there's another way to get access to models that still involves paying a little bit of money, much less. You pay it by the use rather than a subscription. And it uses these open weight models, and it's called OpenRouter. I would definitely recommend you go to OpenRouter if you want to use open weight models. This OpenRouter is like a marketplace platform, which when you ask it for a model, it just finds the best provider for the best price, and you use that provider. Yep.
Quick addition, there's a European alternative to OpenRouter, which is called Codex with CS at the end.
Oh, okay. Codex, thank you.
The website and bring it up again.
I mean, once you see how I work with OpenRouter, then you'll understand anyway. These knowledge is quite transferable, right? You see one thing, you can do it for another. There's a final thing I want to tell you about. That's BlaBlaDor from Forschungszentrum Jülich. They have loads of compute right now that's not being used, and this is for free, as in beer. And if you are at an educational institution in Germany, you get it for free. However, boy, is it complicated to get this thing running. I actually needed Claude to get an account and to get this working for me. But okay, maybe you have some ingenuity and people share their knowledge and you work out how to get BlaBlaDor working. So BlaBlaDor also runs local models here in Germany, right, in Jülich. So it's about as local as you can get. But if you go...
EU summer
yep.
With AI.
Understood. Oh, yeah. And they have all the good models I can see. Yeah. So GLM 5.2 is the model I would recommend you try if you go with open weight models. But you need a coding agent, and there's many coding agents out there, like really many, like 100. It's like you'll write your own. But here's a minimal one that I found to be pretty painless. It's called Pi. I don't even know if I've got Pi. Yeah, I got Pi on this machine. So there's going to be a little bit of more difficulty if you want to use Pi and BlaBlaDor or Pi and Cortex or Pi and OpenRouter. I don't want to get into the details now. You will find tutorials that you can ask coding agents to help you install these things. And then we assume that you've got it running. Okay, so I'll just run Pi to give you an example of what that looks like. Pi update. Okay, Pi looks like this. It looks similar to what I showed yesterday for Claude Code. At the moment, I have a model called Pi 3 Preview. That one's free at the moment. You can use that one. I'll just update Pi while we're talking. Okay. Update Pi while we're talking. So all these coding agents should look roughly the same. So I'm going to do most of today with Claude Code, but that's because I sort of trust it the most. And I have the most experience with Claude. But there are very few differences. These days, these models are just really good. Okay, let's run Pi again. So I'll start with Pi and then go back to Claude Code. Oh, really? Okay, we need an API key. I think that'll work. Yeah. Okay. So once you register with OpenRouter or Cortex or BlaBlaDor, you'll get a thing called a key, an API key. It's a long string. Here you can see it, SK, blah, 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 blah. And you'll have to make sure that Pi or Claude or whatever can access that key. You shouldn't cut and paste that key into your coding agent, because then that will give anyone who can see that key access to the coding agent. Right now, you could copy that and you could use my credit from OpenRouter or my €1.50. So I feel like that's a risk I can take. I know this is being recorded, but this is a key. So people could, in principle, watch a video and say, "Ha, I've got your key. I'm going to use your credit." I don't care if you steal my €1.50, but so you get a key and you have to inform the coding agent about the key. That's how I'm doing it here. There'll be a tutorial you could find to help you there. And so then once you've done that, you can start the coding agent. And then you'll see something like what I showed yesterday, right? And then at the moment, we're using a model, Hi3 Preview, it's called. GLM 5.2 is what I recommend. And now we can sort of start, right? I'm going to tell you about the basics of setting up a workflow with a coding agent where it's actually good practice. Yesterday, what I did was bad practice, very bad. I just said to Claude, go write me a paper, right? If you saw the talk yesterday. Very bad, don't do this, right? You'll get the lowest, worst quality results this way. I want to show you how to get the best quality results and to have faith in what's going on. And for that, I need to tell you about a bunch of things. And the first thing I need to tell you about is agents.md. So before I let Pi or Claude or anything like do a single thing, I need to create a file. And I'm going to get a good one. I guess I'll get it from here. So what I'm going to do is show you a file. And this file is critically important for working with a coding agent. What it is, so an agents.md, MD stands for Markdown. It's a text file format. Agents or Claude.md is a small file that gets read into the context automatically when you start your coding agent. So as soon as I type Pi, it will already have what's in this text document now inside the context. And this is very good, right? Because this is your own system prompt. This allows you to tell the coding agent exactly what it needs to know to get started on what you're doing. Now, here's an example of what an agents.md can look like. It's completely free. There are no rules. You can put whatever you want in it. I will customize one and make a bare minimum one, and then we'll work from that. So, but what does it look like? It's kind of like you woke up in the middle of the night at 2 a.m. and you're completely confused, and someone gives you the bare minimum information you need to kind of orient yourself. That's how you should think about the agents.md. So with this one, you can see there's quite a lot of text in there. It's name of the project, what it is. There's some links to some files. There's some stuff. There's some principles. Blah 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 blah. There's quite a lot of info in there. They usually can be. It really doesn't matter about Markdown. Agents don't. They can read anything. It's like Markdown is somehow just what agents will create. If you let them, they'll create that first, right?
Well, I guess I'm wondering if there's like quality difference, whether I use subheadings like in Markdown, or whether I just like jot it down on the line.
I have not noticed any difference. Like the agents don't care. What I'll do is I'll just delete this. I'm going to show you what I think would be absolutely bare minimum for an agents.md now. And I'm doing that by deleting what's in this one. I would say, you see this hash, that means just create a title. It's like baby LaTeX, right? Implementation principles, these are non-negotiable. Every agent, every session, everything. I think that's important. The first one is where you're saying to the agent, use the file system as your permanent memory. That's what this first principle says. Maintain the work log. Yeah, I've written it this way. I didn't write this, by the way. I did not write this. I asked an agent to create this. So you could just make it much shorter. And then, look, you see how finicky it is. There's all kinds of details and stuff. I probably wouldn't. I'd just delete all this one. Ooh. Right, so maintain the workload. That's something every agent, any starting in this project should do. There should be some kind of trace of the work done, a memory of the work done, and that's what the work log is. So every step, every session, it should create a file under a folder called work log, and it should have this format, and blah, blah, blah. Agents love these kinds of rules. And so now every agent that works on this project, because I'm going to go through agents so quickly, 1, 2, 3, 10 agents by the end of today, they'll all know that they have to write what happened into a work log. And so that later agents can say, oh, I'll look at the work log. Oh, I see 10 days ago this happened. The next one I think is extremely powerful. This has got to do with feedback. In physics, we want to create feedback loops that are fast, tight control loops. And the agents don't often do that by themselves. So you got to tell them to do that. So, fail fast, fail loud. Everything that fails should be loudly errored out. It should be very clear. If something's not working, crash immediately with constant. So I'll just do, so this is something that I think I would put in every agents.md. Boom, that's crash immediately with context, right? So if I want to fail and I want to know why, I don't want mistakes to silently grow in the project. And you got to tell the agents that. This one is my kind of, you've already delete that, that's probably irrelevant these days. Here, some magic words. This is a magic invocation. You can tell every agent, they all know what it means, and it instantly improves the quality of your code, instantly, of your anything you create. Red, green, TDD. So test-driven design was invented by a guy called Kent Beck, along with some other software engineers, like 40 years ago or something. What does TDD mean? It means write a test. And what does red, green mean? It means write a test first before you write anything. Check that the test fails. Then write the thing. Then check that the test passes the test. And then you move on. This is extremely powerful for agents because for humans hate doing this. No human likes to do red, green, TDD, but agents love it. And it's super powerful. This instantly upgrades the quality of everything that gets done because you created an error signal for the feedback loop. What you need is an error signal that agents can act on as fast as possible. They want to test, have they reached the goal? Have they made a mistake? And a red-green test does exactly that. The red part says the test has byte or is non-trivial. It's no point writing a test that already passes. It's kind of dumb. So the red part tests that the test works. The green part tests that the error signal. So red, green, TDD. You say that to your agents, things get better. And this is a bit wordy. That's it. Yeah, I'll get rid of this explanation stuff. Man, they're so wordy sometimes. Okay, we'll get rid of exhaustive verification. That's just, this is stuff specific to the thing I copied from. That's stuff specific from the thing I copied from. This one I like. So often agents are trained to just get quick fixes done. They're not trained to do it properly. And so if you tell them, actually, probably bugs are not this all looks specific to software engineering, but it's very relevant for writing LaTeX as well. Never assume it's shallow. Okay, it's a simple statement, but if you give permission to the agent to assume that a bug is not shallow, then it'll do more work. Get feedback fast. You can see me just going on about this feedback point. I don't think you need that for this. It's already kind of been said at the beginning. Fail fast, fail loud. Research steps are explicit. No, you can just dump that. Yeah, skepticism, I think this is also an important one. Agents are trained to be helpful. They're not automatically skeptical unless you ask them to be skeptical. So I think that's very important. So let's renumber these. 3, 4. Be skeptical of everything. And this happens so often, so often. You run an agent doing something, and then it says, this other agent gave me some information, I'm going to act on this. And then if you say this, be skeptical, it says, oh, I'll double check what that agent did. Oh, I found a mistake in what it said. And I caught maybe 40–50% of problems just by asking it to always be skeptical. PRD-driven development. Here's another software engineering term. PRD, product requirements document. These models are trained to work with these documents. A PRD is like a one-page thing that says what the project is. the goals, the non-goals, it's the users or what you expect, what's the end state of the project when it's finished. Like, it's just kind of like a statement of what the project is. And a PRD, they love it. It's also an error signal, right? They know that they haven't finished until every part of the PRD has been addressed. And so that's why it's very important to just explicitly say that. And then I can delete this stuff. First is fifth rule. You don't have to follow my rules. Other people have different rules. These are ones I just have been using for a while. Blah, blah, blah. This is all for project now. I'll get rid of all this stuff. And then, yeah, I'll leave this stuff here. I'll leave it here for, this is something I like. You don't have to like it. So I'd say up to 5, up to rule 5, you'll be kind of fine. Like if you have a Claude or an agents.md that looks like that, then you'll be good. Like it'll improve everything a lot if you have these rules. But then you can add other stuff as you learn things. You can install programs that help the agents. One of these agents programs that we like is called Beads. Beads is a so-called issue tracker. It runs on the command line. The agents can create an issue, and it's like a database of things that need to be done. And the agents can query this database, and then it says the next thing that should be done is this. And then so they can leave like a little, things they noticed in this database so that future agents can deal with it. And it often happens that an agent says, oh, I noticed that there's this bug. I'm going to register this issue with Beads. So you can use it or not. If you don't use it, then that's cool. Like they'll do it some other way. Well, that's all Beads crap. Drop that. And then you might want to do this at the end of every session. The agents have to do some things before they stop, right? One is, file issues for remaining work. So if they didn't manage to do everything, then they have to say that they didn't finish it. Run quality gates, so they have to make sure things look nice and check that tests pass. They have to update issues to make sure things are and then if you work with Git, but we won't talk about that yet. Clean up, verify, blah, blah, blah. You can add all kinds of stuff. But I guess I'll leave it like that. 1, 2, 3, 4, 6. Good. That's agents. We spent 10 minutes on this, and I think this is 10 minutes well invested. Once you get into the habit of making a good agents.md at the beginning of anything you do, this will improve the quality of everything that happens afterwards. Everything gets better. Good. So now we have an agents.md in our folder. There it is. And I can start Pi again. And now, Pi has read it. You can see it's read it. It says here context agents.md. So it now knows. I think I've actually covered a bunch of the points I wanted to cover already. So now might be a moment for questions. I have some notes. Just consult my notes first. Okay, installing, red, green, ground truth, worklogs. Okay, ground truth I haven't touched. We'll do that in a second though. Okay, are there any questions so far? Is everything kind of clear?
This may be a quick random question. So, what decides what gets loaded into context in this case? Is it just the agent MD, or is it also any file in the folder?
So the bare minimum is that it will load agents.md into the context first. What happens then? Unclear. So the agents might read the agents.md and decide to read another file based on what they see in that agents.md. Because in the agents.md, you might say, read the work log. That might be one of the first instructions. And then they'll go, okay, I better go read the work log. And then they'll go read that. And then all of a sudden you've loaded more. Does that help?
Yeah.
Yep.
Usually when I install software these days, I ask ChatGPT how to do it and what their comments. Would it come up with similar things, or is it they don't use open?
They try to be helpful. Like if you ask ChatGPT how to install Claude, it will tell you how to do it. So I have not found it unrecommending competitors. Like even at OpenAI, they use Claude Code, by the way. And vice versa. So at Anthropic, they use ChatGPT. All of this. Listen. Yep.
I even like maybe more tailored question. Like, for instance, if I want to create an agent to help me, I don't know, some precise research, and I don't know, like in my understanding, I just trust about 10 papers that I studied, and then know that in some way there is something that is related. If I write like in the rules, say, hey, just use these 10 sources, is able to understand and not going, you know, around creating fake things. I mean,
Okay. That's actually on my list of things to talk about.
Okay.
We got to say what is the ground truth. So, but before I get to that, I want to show you how to write your own coding agent. So the very first thing you should do, I mean, okay, how many of you here have done at least a little bit of programming in undergraduate? Like just a little bit. Great. Probably you've seen Python, yeah? Is there any programming language other than Python that people were taught in undergraduate?
It's R.
Which one?
R.
R, okay, yeah. C, yeah, C. Java, okay. These are all fine. Coding agents can work in R, C, and Java. They have no problems. And the first thing you should do, your first exercise with a coding agent, like if you don't do this, then you're making your life simple. You're really missing out on something you like, is you're going to write your own coding agent. And this is how you will do it, right? Write me a minimal Python coding agent. Oh, I forgot the literate coding. I'll put that in a second. The user wants me to write a minimal Python coding agent. Okay, the minimal coding agent that can read files, edit code, and execute commands. That's what I said yesterday. Let me build this step by step. So if you've done Python, then you already might be familiar with what's happening here. And this is so crucial because this is probably the last code you'll ever read. You'll read through that coding agent, and then you'll understand how a coding agent works in your favorite language, be it Java or C or Python, right? Or R. You can write a coding agent in R, no problems, right? You can write it in whatever language. Okay, I've created a minimal coding agent. Fortran 2000, it's fine with that.
Straight up assembler.
Yeah.
It can do that, no worries. I have got a coding agent writing in assembly, x86, 6502 assembly. It'll do that. But probably you want to choose a less verbose language, so it's a bit, so you can understand the whole thing. So there it is. It's actually created the first coding agent. We're going to take a look at it. And then yep.
Problems sometimes they tend to just add lines of code and do not remove like whatever. It's not necessary anymore. Do you have a specific statement in your HLMD projects to like enforce a clean repo or just adding?
So I tend to be one of these accretors, not deleters. So I'm one of these people who just likes to just add stuff. And I use version control and with multiple branches, and I add stuff in Git commit branches, work trees, and so on. Is that what you're talking about, or
kind of related? The problem is that often when you say, "Okay, look, that's the current code. Please add this and this feature," or sometimes it might be necessary for a human designer would decide to take some code parts out of it, define a new function, and then refactor a lot of code.
Oh, refactoring, yeah.
Remove a lot of old code which is now obsolete or not used anymore or had to be changed accordingly. And these agents sometimes have the tendency to actually just increase code length. So usually when you give them commands, you will see like 200 lines added, 3 removed, which
sort of smelled like
okay. Starts to smell fishy. Do you have an on-purpose command to prevent that, like in your MD or?
No, but there's something I'll show you what to do straight away, which is code review. So I relentlessly code review everything. So every line of code that gets added, I'll often have 2 or 3 agents review it, and also every so often I'll ask agents to review the whole code base and look for duplication, to look for code smells, to look for bad documentation, stuff like that. Okay. So that's an extra feedback loop that we'll get to in a sec. I think when you're creating, you tend to add But then, as you say, you get lots of duplication and garbage and all kinds of stuff. And then you can't sort of stop that happening as they add, because they only have their little context window. They don't really know what they should delete. They can't see the whole code base usually and understand they've just duplicated something somewhere else. But you can do this code review, and then that's a very powerful way to.
Wouldn't the code review not suffer from the same problem that the context length is exceeded and the code is too long?
It's true, but you have an orchestrator agent send out sub-agents, and it keeps the overview and it looks at summaries. Okay. Now, I'll show you that in action in a minute, but let's just take a look at our minimal coding agent. No, I don't want to run it. Open with Sublime. Okay, so this is what a minimal coding agent looks like. I don't know Python, I confess. I learned MATLAB when I was at university. If you know Python, then you'll look through your coding agent and hopefully you'll understand kind of what the bits and pieces do. There's these tools like list files, and here's the agent itself. I don't know if you know what this means, but hopefully you do. And then while true, and here's the while loop for a coding agent. I don't know Python, but I know what I'm looking at, right? It's you're waiting for some input from the user. And then if it's not quit or not help, then I don't know what that, I'll change some directories and then execute commands and so on. And so it does this in a loop, and that's what I showed you yesterday. I won't spend time on that. That's your own journey. If you don't understand the code, ask it to explain it to you. So in particular, the next thing I'll do is, okay, it already does explain it to me. Right, here's what it created: a minimal thing, requirements, depend. I've created a minimal coding agent for you. Here's what was built: quick start, interactive mode, full version. The agent does the following things. Okay, so that's a homework exercise for you, and get it running, right? And explain it to me with an example. Let's get used to saying things like this. You didn't write the code, you're not expected to understand it, right? And now, look, there it goes. It's giving me a little tutorial about how the coding agent works. This is a very, very powerful technique to understand what agents are doing. And so we'll let that run for a bit. And while it's running, I will show you on the screen here, you can see some important information. This is very, very helpful. You see this 3%? That means I've used 3% of the context window. That number is, like, you should have your eye on that number all the time. When that number hits to about 60 or 70%, you've got to ask yourself, do I want this agent to continue working, or has it done its job, and can I hand off to another agent? Right, okay. You can see it's done a lot of stuff, right, to explain this coding agent. This is the first job for you, because once you've done this, you will understand all code.
Just from the web. I mean, it's completely different when you use the agent. I mean, when you use the agent, you forget everything.
It forgets everything.
Okay. But in terms of capability, I don't know if you, open an agent to say, oh, let's do this, and then, I don't know, maybe you don't like so much, so you may be asked to do it better. I mean, until the moment that you don't quit, how much is the capability of an agent?
It's hard to answer that question.
Okay.
It depends on the model. It depends on how you used it. It depends on the context usage. This is where your experience becomes very, very important. So what I know about Claude and ChatGPT isn't so helpful with High 3. I can't really answer the question for this agent, actually.
Okay.
I haven't used it so much.
But my question was, in some sense, like, I don't know if you create like a team of agents, the capability can scale with the number of the agents that you are using, or there are no correlation between the capability of continuing a job for long, or
it depends on parallelizability.
Okay.
If your task is parallelizable, it can be broken up into chunks that can be done by autonomous agents that don't know anything. Capability scales with the number of tasks, number of agents. If your task is serial, so you can't get to the next step until you've done the step before, then you can't parallelize, right? It's not helpful. And you'll learn very quickly how to parallelize work. You'll think, can I do this independently? Actually, I can. I don't need to wait until this job is done. I can do another agent. You get a feeling for that. So, yep.
Working high when we are creating our agents modifying or can we directly for the export file?
I'm showing Pi right now because I have a suspicion, this being Germany, that the people here would prefer to have an open source, open weight alternative. I would say Claude and Codex are much better.
For creating the agent or
Both, for everything, in all tasks. Their capabilities are better, but not that much better. Yep.
When you're thinking about like parallelizing your work and stuff like that, do you explicitly mention also in your agents file that you want for those tasks to spawn sub agents? Because
Yes.
yeah, because most of the time, I mean, they're trained now to spawn sub agents anyways.
Yeah.
But sometimes you really explicitly want to tell them, hey, I know this problem can be broken down, but everything spawns separate subagent and pull it back.
I definitely say that.
Yeah.
I often don't even put it in the agent. I think agents on MD, I just say it in the prompt.
Yeah. Yes.
Yeah. And I often say don't spawn sub-agents. Like I hate it when it spawns 10 sub-agents to do something where I know it only needs one. So that's a bit advanced. At the moment, I'm at the point where I'm trying to explain now that I quit the agent and I started a new one and it has complete amnesia. This new agent, all it knows is that agents.md file. It's forgotten that it wrote a coding agent. It knows nothing now. So what do you need to do? Well, you've got to get that agent up to speed somehow. And so the bare minimum you can type, and this is already very helpful, is to tell it to do this. So agents will say, okay, I got to understand what's here. So now it's going through, it's reading the stuff that's written in this folder. It's realized it's project to do with coding agents. It's read these Python files now. It's read some requirement. It's reading all this stuff, and it's realized I'm not using version tracking. Let me check the simpler version of the agent. So yeah, it's really going through, you can see it's going through and understanding all the files in this folder. So it's using the read file tool, it's putting it all in its context. Okay, now I have a good understanding. Here's a summary. So this is the basic thing. Whenever you start a project that you've been working on for a while, you start the agent, you know it has no memory, it doesn't understand anything. You've got to get it some kind of understanding. And so this work log that I showed you means that it can go read the work log and see what work was done. It can look at the PRD if you have one, and read what the goal of the project is. It might read some files like it just did. And then it'll give you the summary. And now this agent, and now we can get to work, right? So that's where I will stop with Pi. I want to just emphasize Pi is now with this high 3. You can see how much money I spent so far today, right? Give you a sense of how much it's cost, less than €1 we've spent so far. If you have €1.50, you can now have a sense of how much you can create with €1.50. That's with these open weight models. I'm about to change to a different model, namely Claude, and that's a much more powerful model and a much more expensive model. Oh gosh, I mean, okay, let's see. I'll get it to, it doesn't know what's going on here either. And you can see, so this is all read only what it's doing at the moment. It's just reading stuff. The minute it tries to create something, it'll ask for permissions.
Is this hard coded or is this trained asking for permissions?
We have to believe them that it's hard coded. It's not open source.
They claim it is.
They claim it is hard coded. If you look, Codex is open source, by the way. So in principle, if you look inside Codex, you'll see that it is hard coded. Just permission. Okay, create a small agent in what's the most obscure programming language? Fortran. What was it? 20. Let's do Fortran. F# that's too easy actually because they
I guess no one knows.
Yeah. do it in OCaml or something.
Yeah.
So I just wanted to ask permission so you can see what that looks like. And then it gets really annoying really quick. See, Pi didn't ask for permissions, which I found a bit odd. I would have expected Pi to say, do I have permission to create this file? It didn't ask permissions. So this is not what I call default kind of behavior. So in principle, Pi could delete stuff, but
I think it's like what they're advertising. That's minimal harness, which just like
yeah, it has minimal stuff, right? So you better be a bit careful.
Do you know how this in practice is implemented, like the fact that there's this hard-coded limits?
Do I know how it's implemented?
Yeah.
I mean, the source code, you can, one of the things agents can do is they can uncompile stuff.
No, I mean, I know I could ask it, but I'm asking if you happen to know it.
I mean, I do. The source code for Claude Code got leaked, but they didn't need to leak it. We could have just reverse engineered it with a coding agent, and we would see that it's hard coded as of version whatever, right? It changes versions every day, so I don't know. Maybe today it's not hard coded. Okay, so that's sort of like I'm doing kind of obviously software engineering stuff here, right? But this is not what you're here for. We got in the next 10 minutes, I want to show you a workflow where you can do research. And that, I think, is the thing you're probably here for, right? But we have to cover, well, it's writing as well without permissions. I think permissions have changed in the past couple of months. I would have expected to say, may I write that? But now it's saying, probably if you remove a file, it's going to ask permissions, I'm pretty sure.
they're still very annoying in Android.
Okay. Yeah, I don't know. So I'm a bit unsure now about permissions. So your mileage may vary with the coding agent. I know it used to ask all the time, but now I suspect it'll ask permissions if it needs to delete a file. I'm sure it will escalate and say, may I delete this file? If it changes directory and comes out of the folder where you are, I'm sure it will ask if it can do that. I'm sure about this. Yep.
Did I see that correctly? That you're inside Claude now, but it makes reference to the agent file you wrote before.
Correct.
These commands. Does it do that automatically?
Yes. Claude Code will read the agents.mp file, and it will then explore the folder it's in. Oh gosh, wow, look at it. It's so it's having a go with Fortran. So we may get the world's first Fortran coding agent. It's really good at Fortran. I know this. Good. Well, let's let it do its thing, and let's start a new folder. Let's talk about doing research, right? So I'm going to say we're predominantly theorists here. Is that correct? Anyone who's an experimentalist? No. I mean, if you're an experimentalist, wow, you've got a lot of capability here. But you're not, right? You're theorists. So here's the kind of, what do I want to do? I want to go into a folder. One thing that you might want to do is start writing or doing exploratory science. I think this is kind of a cool thing you can do. And here you're really up against the context. You're up against hallucinations. You're up against all kinds of challenges. Now, I'm not going to assume you're proving theorems or anything like that. We want to discuss a workflow where you can manage the context, keep ground truth local, and be able to add to a growing document of knowledge. And here's a workflow that I've been experimenting with, and I think it kind of works fairly well now. And I call it the lab book workflow. It's pretty simple. I'll get Claude to explain it to us. So first I'll get it to, see Claude, I've just started a new Claude. It has no idea what this folder is about. Now it's going to read all the stuff, and it's going to do that for a while. And sorry?
This time here, this is an agent that we're releasing.
No, Claude Code is a commercial agent.
Yeah, the command that just
I ran Claude. Oh, that's a skill. Yeah, we could talk about skills, but I don't think it's very important. A skill is just a small markdown file. So yeah, okay. when I type /familiarize project, there's a little markdown file that says, when you see that, this means go look in the folders, go do this, go do that.
But shouldn't we supposed to do that every time it looks at the agent's markdown?
Yes and no. There's levels, right? You know, when it starts with an agents.md, it'll do the bare minimum it needs to do, because you don't want to fill your context up with garbage. And then after that, you might say, okay, work out more deeply what's going on. And that's context, different word, context, that's situation dependent, right? If I wanted to understand better what's going on, it should go off and read what the last agent did. It should work out what the next work is. It should, and that fills the context up with more stuff. I don't want to do that unless I activate that. So generically, I want to keep the context as clean as possible, and I only want to put information in there when I tell it. So familiarize project is a way to give it permission to learn more. And so here's this project that we've got. It's called Where Are We? Okay, it's all full of jargon now. Open work, blah, blah, blah. Okay, what I want to do is explain, okay, yeah. Explain the work, how the work actually happens. So there's this thing I learned from experimental physicists. They have a thing called a lab book. It's by law, you have to have it. And in it, you record everything that happens in the lab. It's a diary of your actions in the lab, and it's going to record not only the successes, but the failures, right? All the things that didn't work, the processes you did, the things that you tried. And I thought, wouldn't that be interesting if you did that for a theorist? What's a theorist lab book looks like? And this turned out to be very helpful. So it's a repository of files that grows in small, dated, traceable pieces. And that's super important, because every piece you add has got to be created in the context of an agent somewhere, and we don't want to fill that context up, right? So it's all about decomposing knowledge into pieces and only calling it when we need it. So nothing is written from memory, right? That's one of the rules in the agents.md. It's one of the rules is you may not write anything down in memory. If a formula, number, or claim about something goes into the notebook, it has to point at a specific line in a specific paper stored in the repository, or at a calculation someone did here, or at a program that was actually run. So this is this hallucination risk, right? With this workflow, agents can't hallucinate because they're not allowed to write down an equation without having the reference. And the reference has to be to a paper that exists on the hard drive. And if the paper isn't there, the work stops until it's fetched. This exists because the failure everyone falls into is writing something that sounds right and is confidently wrong. This, I think, is the failure mode of all LLMs from the beginning to the end. Even the most advanced LLMs today that were released last week still hallucinate. They still confidently claim things that are wrong. Choices get written down before. Choices get written down before they're used. The field is full of conventions that look interchangeable and aren't. Which direction counts as positive, blah, blah, blah. Okay, so it's a bit more specific to this project, but surely your own field has the same issue. So we have a thing called a conventions file. Like, you know, if I talk about matrices, then they have to have this notation. If I talk about Hamiltonians, then they have to look like this. And you have to agree to these conventions, and you're not allowed to use them unless you follow the conventions. And that stops this notation drift that you see in human projects all the time. You talk about H, and then all of a sudden H is a Hilbert space, and then all of a sudden, you know, H becomes a variable, and then you're completely confused, right? LLMs are confused too. So there's a convention. Anything, and so there's a file where each choice is recorded before anything is built up. And the rule of thumb, when something doesn't add up, assume you mixed conventions before you assume the math is broken. Anything computed has to be recomputable, okay? Like reproducibility is very important in science. So if you have a numerical program, it better be possible to run it. So it better be there. And it has to have some tests. And here's the rhythm of a session, right? The written notebook is broken into small self-contained chunks of about 200 lines. 200 lines is kind of a magic number. People talk about 200 a lot. It's a small chunk that an LLM can work with without getting confused, and I don't know, it's changing, but they each have an ID, whatever. And alongside that runs a work log. You've seen what that is. It's a diary of what was done and why and what went wrong. And each session picks up one small piece, does it, checks it, writes the diary entry, and then pushes. So if you use version control, pushing just means sending it to a repository host like GitHub or something like that. You don't have to do that. And the most recent one did something. Okay. This runs on a laptop, so computations are deliberately small. Okay, so that's a workflow that I've experimented with, and it seems to work really well. Like the thing about chat histories on the web is you've seen it, right? You can get only so long and then it corrupts. I wanted a document that always grew, was always correct, and never degraded. And with this workflow, I've so far managed to do this. And I'll give you an example of some pages from that workflow. And I'll show you the report. So I got this is the lab book here. This is what it looks like. I'm at page 170 something. But let's look at the front matter. So you probably can't see that very well, right? So at the beginning of the lab book, this is a reproducible research lab book, blah, 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 the North Stars, blah, 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 blah. Right, I didn't write any of this, by the way. I mean, the agents wrote this. And then I'll go through some entries of here's the rules, okay. Some state, this is where we're at, blah, blah, blah. I just want to show you an entry, what it looks like. Let's just pick one. Yeah, so this is what an entry looks like. It has a title, it has some sources and dependencies, so it actually explains where the notation comes from, where the conventions we are using. It does some math, writes something down, and then in about, write some stuff down, and then it should end after about 3 pages. And this is a chunk that you append to this lab book. This is a lab book entry, and it also I have this dependency. I insist that it writes, what depends on what, and then it talks about stuff that is in scope and out of scope, and some things that it learned in this 3-page append. So this is how I work. You explore theory. You think, okay, I have an idea. Let's check that idea out, and then the agent might spawn some other agents, might download some papers, and then come up with a derivation, and then you say, put that in the next lab book entry, and then it'll add that on, it'll do all those checks, and then at the end, it just creates this living notebook that continues and continues and continues. And I've got faith that everything is kind of stable and nothing's rotting or drifting as we add to this. And you can generate hundreds of pages this way. It's very, very quick. Great question. The answer is I don't know, like the honest answer. So the way I would recommend you do this is if you want to build a bibliography database kind of thing, you could try one of these commercial programs like Zotero or something like that. I've gotten so lazy now that I just say, work out your own database and download all the papers. So agents are great at making databases. And I'll just let it create its own database. It'll store all the papers somewhere on the file system. It'll create an index. And I don't care how it does it. But
that sounds a little bit like a rack with, like builds a rack internally. Wouldn't it be also an option just to on purpose, download a rack system because they have like this transformer hash mapping system, and then say use the rack instead?
It's not a rack. So RAG is terminology. What is it? It's
yeah, that's a good question.
Sorry? Thank you. I don't use RAG. I just don't think it's worth the effort. The context windows are now big enough. And what do you really want when you want to get context? When you want to get in, a RAG is a very sophisticated machine learning model for allowing data to be associatively queried in large sets of data. It's kind of my caricature, right? I know it's more complicated. It's a lot of work to set one up. I found it.
Well, I think there's GitHub repositories which do that quite well.
There are, but I just haven't found that they perform very well in comparison to just getting the agents to download all the files and write an index.
Okay.
The agents look at the index and they're like, oh, I know that paper, because they even know the papers. Like most of the papers are in the training data. And not really, to be clear, right? The purpose of the bibliography isn't for them to learn anything. they already know the papers. The purpose is just to stop them hallucinating equations in the papers. So any paper that came out before January 2025 is in their training data.
I'm still not sure I fully understood. So all what one of us has to do is to download to pay for it. Probably some 200 euros.
Well, you don't have to go that high. You can start with 20 euros a month.
Okay. And 20 a month. Okay. And then as a part where it searches the web, which is something, that is automatically included. So you go into Pro and it will automatically use the search engine of
Yeah. No. It doesn't use search. It uses whatever your computer can do. So your computer has Chrome on it. It can use Chrome. It can make web fetches. It just would do anything that your computer can do. It doesn't use Anthropic's.
So it's basically it, but then it also ChatGPT basically out of
well, ChatGPT has their own version.
Yeah, but so far, I mean, they have a data center somewhere which fits the work. And now my own computer is doing it all. Yeah,
but I mean, the work is still being done by the LLM.
Yeah,
is running on 8 H200 GPU. So this is going to. I'm just asking you to find some quantum optic result that's cool, and then to find the top 10 papers. It's a bit ridiculous. It's doing. What is it doing? It's doing web searches, right? These web searches are just using services on the web, not necessarily Anthropic. At the moment, I do know it is using an Anthropic service to get a bot notation, but it could be using just Google. You could ask it to use Google to do this. And it's now did some web searches to answer my question. What's the top 10 result? Whatever the highlights of 2026, right? And it's going to now download using the services on my computer, these papers onto my computer. So nothing is on Anthropic services except for this thinking, for this cognition. Yep.
So that's what I added because I found that it's super helpful to add in your agents and video or whatever, to specifically tell it to download the text source of archive because it always has problems with PDFs.
That's right. Yeah, it will. For some reason, they always download PDFs, and it's not a great format for them.
They always mess up where things are. Text is just text, so they know what to do, but PDFs are.
Yeah, and I don't know why they do it. So I said, go download the source for. Yeah. So it knows that means the text source. And you can see it now. Find archive, web search. Now they're all looking. I've got 3 agents now running under this agent, and they're independently doing work. This photonic quantum computer scaling, teleportation, so they're all looking around finding stuff, and you can see what they're doing. They're fetching, they're changing directories. Some of them are downloading the text source right now. Yeah, so that I hope helps explain. Anthropic's services are not, or open AI services are not running these commands. They're running on my computer here. And we can let that run. Are there any other questions?
Do you roughly know the overhead of like doing this with a local agent versus doing this like on a web interface where they have like?
I wish I could answer that better actually, but it seems like the overhead is massive. Like if you use the chat interface, like the context is filled. They don't tell you, but I can tell when the context gets filled. It's like it seems to get filled really quickly, and my query gets used up really fast. And so all I can say is that on the web it seems really expensive. I can't give you the numbers. Very hard to give you the numbers.
Can I tell it when I make a directory that it should not look anywhere else?
You can say that,
and it will do.
It will. I mean, it will try, but I've seen it. You say that, and then you might ask it to do something that inadvertently wants it to look somewhere else, and so you might say, "I really want to understand," and then don't look outside this folder, and then it's got a problem, right? It's like I want to be helpful to the user, but I know that to get the best information to answer the user's question, I should look elsewhere, and then it has a decision to make. And the decision sometimes goes one way or the other. Right?
You always have a lot of
and file reading, and they can execute LaTeX. And I mean, if you're doing massive numerics, then probably you know what you're doing, and you need anyway. So I'll show you why we're like we talked about this ground truth. Oh, it hasn't created it yet, but it's working away, right? It's making a little database of papers. Just like at the beginning of the seminar, you know, you asked, what can I say? Only use the papers here. Yes, and this is how you can do it. We can look at the Fortran agent and see how that worked. Look, so we built a working Fortran coding agent and verified it, not just compiled it. Okay, what it does, blah, 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 blah. Okay, so there you go. We have a Fortran coding agent. So if Fortran is your thing, you can do it too. Yep.
Would you ever use these? Would you ever use your own agent? Or,
I did for a while. Okay. Because I really wanted to know, right? I think everyone here is probably curious. And if you're curious, you probably want to know how things work. And so I kind of forced myself to use my own coding agent for a little while until I got really annoyed at it. But, you know, you can also improve your own coding agent. Like you can get your coding agent to edit itself and get better. And I did that for a while. And then I was like, this is too much work. I'll just use someone else's. Yeah.
So was it taking something like Jarvis agent or open flow like self-evolving?
So Pi is one of these self-evolving ones as well. They're all self-evolving. If you can edit the source code, then they're effectively self-evolving. Yeah. So I like Pi because it's kind of minimal. There's the other one. I've tried a bunch, but like I don't hate any of them. They get the job done.